Hello, friends. You are welcome to another session on Code with Math. If you are yet to subscribe to this channel, please kindly hit the subscribe button so that you can be notified immediately my videos are released. And if you like what you are watching on this channel and you know that you are learning, please do well to like my videos, share, and also comment and give your feedbacks. Thank you very much. So, as at the last session, we started the topic understanding operators in C. We defined operators, we looked at different classifications of operators, and then we considered arithmetic operators. So, for better understanding, if you're watching this for the first time, please kindly revert to the previous video. So, today we want to continue, we want to look at relational operators. So, relational operators are binary operators. They require two operands and they compare the value of both operands and give a Boolean result. A Boolean result evaluates to true or false, which will evaluate to 0 or 1. So 0 being false, 1 being true. So it means that you can use the result of these relational operators in your conditional statements. We would be considering conditional statements immediately after we complete the sessions on operators. So you can check for equality with the equal to the double equal to in C. You can check for not equal. You can check for greater than, less than, greater than or equal to, less than or equal to. So without any further ado, I want us to see this in practice. Let's head over to our VS Code. So right here, you can see the code from the previous session. I've commented that all out. And then I want to start with today's session. So I'm just going to test the Boolean expressions to save time. I would want you to get some practice on your own. So %d, of course, new line. So I want to check A equal. So for you to test equality, you use the double equal signs, right? Equal B. So of course, is A equal to B? Is A and B the same? A is 10, B is 4. Is A and B the same? No. So let's see what we get here. So this time around, I would name this eq1. So let's run eq1 as eq1. So you see, it evaluates to 0. But let me make this 10. Let me make this 10. So let me make this eq2, right? And then let's run it. You see this? This is true. Another way that we can test, let's keep this as, let's make this 5, right? And then let's say A equal B plus 5. So you see we are combining different operators now. So what is going to happen here is it's first going to add this and then compare to this result. So let's see this in action. So we still get 1 because B is 5. 5 plus 5 is 10. So it means 10 equals to 10, right? 10 is the same as 10. So that's why you have that. So let me remove this. I want to make things easier. So let me just copy this. Let me comment it out. And then this time around, let me check not equal. Not equal. So this is A is not equal to B. So is this true or false? A is 10, B is 5. So A is not equal to B. So that should be true, right? So let me save this as NQ. NQ1. Oops, sorry. So NQ1. So let's run NQ1. Wow. So this is true. A is not equal to B. So what if I make B also 10? Let's run this. Let's recompile as NQ2. And then I run NQ2. So it's 0, meaning it's false, right? So because the two of them right now, they are 10. So that's the comparison. So the next is greater than. So let me go back to 5. So we can say, is A greater than 5? So we're checking for greater than. A greater than B. That's 10 is greater than 5. So what do we get? Let me use G. So A is greater than 5. So that's correct. So is A lesser than 5? Is 10 lesser than 5? Oops. Compile. So we get 0, meaning it's false. So this expression is false. But let's say we make B 15. So let's do L2. L2. So you see 10 is lesser than 15. So this expression becomes true. So moving forward, we can also check for greater than or equal to. So let's return this to 5. So is A greater than or equal to 5? Let's see what this evaluates to. GEQ. So let's run GEQ. So of course it's true because A is greater than 5. So let's make this 10. Okay, let's make this 10. So GEQ1. Oops, compile. So GEQ1, let's run GEQ1. So you see GEQ1 evaluates to, it still evaluates to true because they are both 10, 10, right? So 10 is of course equal to 10, right? So that equality is correct. But by the time we make this 11, what do you think is going to happen? Oops, yes, right here. So we evaluate, it evaluates to 0, false, because A is 10 and B is 11. So if we come back and we use greater than, so let's compare. A is less than or equal to 11. So let me just use L. So LEQ 2. So you see this is true. A is actually less than, 10 is lesser than 11, right? So that evaluates to true. And then I could change this. Let's go back to 10. So let's compile this as LEQ1. So by the time we run this, so you see this is still true because A is 10, B is 10. So they both they evaluate to true. It evaluates to true because A is still equal to B. And then of course, if we bring B back to 5, let's so it becomes 0 because A is actually greater than 5. So this evaluates to 0. All right, guys. So I believe this is a brief and very good explanation of the relational operators. So we can move forward from here. Let's go to the next operator. Okay, the logical operators. The logical operators. So the logical operators um, are actually you use them to actually develop your logic. So you develop a logic, you compare two conditions or two relations and try to evaluate them, evaluate that comparison, and then you you can make an action from there. So logical operators will still evaluate, they will still result in true or false. So let's see, the there are three logical operators, right? The and, the the double pipe, and then sorry, I said the and is actually the ampersand, right? So double ampersand, double pipes, and of course the exclamation mark. So the double ampersand is called your logical and operator. Logical and operator. So if the both operands are non-zero, that means if both of them, if the two operands you are comparing, you are using are not zero, so it means that it will evaluate to true. If both of them are non-zero, the condition becomes true. But if either of them is 1, if either of them is 0, if either of them evaluates to false, then the condition becomes false. Let me take that again. If both conditions that you are comparing evaluate to true, if both conditions you are checking evaluate to true, that means they are non-zero values, then the logical and operator will evaluate to true, which is 1. If either of the two values evaluates to false, 0, then this condition evaluates to false. The double pipe, which is a logical OR, if any if any of the two conditions evaluates to true, if any of the two operands evaluates to true, then the condition becomes true. If both of them evaluate to false, then the condition becomes false. And then the logical not operator, um, which is shown by, which is represented by the exclamation mark, reverses the result of the condition that you have already. So it's actually a unary operator, and it reverses the results of whatsoever you have already. So if you have a condition that evaluates to true before, by the time you use the logical not, then it evaluates to false. And then if it was false before, then it evaluates to true. Okay, so let's see this in code. So right here we have the value of our A is still 10, and then the value of B is 5. So we're going to maintain that. So let me just copy this. So here, let's say we have A less than B. Okay. So yes, this is A less than B. And A is greater than 7. So what do you think this is going to evaluate to? A is less than B. Is A less than B? A is 10, B is 5. So A less than B would be, A less than B would be, we evaluate to false, which is 0. And so immediately, okay, immediately, when one, an explanation I can give you, there is something called short circuiting in programming. There's something called short circuiting in programming, which would be, it's actually a good concept for us to understand. And I will explain that this may be useful for anybody who has had an experience in programming. But if you are coming into programming for the first time, it is not by force for you to master this right now. You could master it later on. If I have a function, we'll discuss functions later, that returns a value, and that value is non-zero. So of course, it means this will evaluate to true. If I put that function here, let's say I just use some function. So I call some function here. Some function can be any function, right? And the result of this some function is it returns an integer, and that integer maybe that integer is, the integer is going to return to me would be, let's say it's going to return 5. Okay, so what this means is that by the time I run this function inside here, this function would actually run, it will actually evaluate. So it will actually evaluate, it will do everything it's supposed to do, right? And then the value of that function would now be placed here. So if the function returns a truthy value, then immediately, because this hand has been seen, then whatever expression you have here would also be evaluated for its value. So if this also becomes, let's say this is another function. So if this another function also returns a truthy value, then all of this block, right? Oops, sorry. All of this will evaluate to true. So what we will use that for is, okay, before I say what we would use it for, if I have a function here, let's say I want to perform a logic that I only want this function to run if this function comes back as true. So I could write this expression like this. I could say some function. So once some function comes back, right? And then I will now put this logical hand and say another function. So if this function, for example, returns 0 on failure, so that is when it's going to work. If this function returns 0 on failure, so it then means that if this is 0, it means it failed. Or if this is null, it means it failed, right? So then once there is an automatic 0, once there is 0 in any of in any of the returns, right? Especially in the first one, in the first part of the once the first expression evaluates to 0 and you are using this logical hand, then it means that there is no need. Then it means that there is no need to evaluate the second expression because both expressions must be true for this to return true. So the concept of short circuiting, you can now use this hand operator, right, to say, okay, I'm going to run this function. If this function returns a true value, then I will run another function. But if my function is going to return 0, for example, or null, which means failure, if it returns a failed value, a value that indicates false, right? Then, because we are using this AND operator, then we are now saying that don't carry out whatsoever is here. I don't know if I did justice to that explanation, but if you want me to do a separate video on that concept, if you want to have a separate video on that concept, please kindly let me know in the comment section. Then I will do a separate video on it. So, but coming back to what we were discussing before, so we were saying, let's say a less than 5, a less than b, right? And then a greater than 7. So right here, because a is not less than 5, there will be no need to evaluate this, and then this automatically becomes 0. So if I try to print this out, logical land, right? So if I run land, so you see this becomes 0 because a is because a is because a is not less than 5. So but if I do a greater than 5 and a greater than 7, then of course this is going to return positive. So for you to understand that, then let's go to the next operator, the double pipe. Sorry, typo. Okay, so of course this says if this is true, and okay, let me explain it this way. So the logical hand will return true if either of them is true. If either of them is true, right? So that means we are going to check here. If this is true, then there is no need to check this expression. If this is true, if a is greater than b, of course there will be no need for a greater than 7 to check if a is greater than 7. And if a is greater than 7, if a is greater than b, if a greater than b is false, right? So it will now move here and also check this expression. If this expression evaluates to true, the result will be true. But if this expression is also false, then the result will be 0. So this will only evaluate to 0 if both conditions are false. But if either of them is true, then the evaluation will become true. And of course, like I said, concerning short circuiting, you can also use this to short circuit, right? You can say, if I have a value here, if I put a function here, say only run, let's say I have, again, some function, right? Let's do some function. And then we have another function. Okay, so what this is going to translate to is only run this function if this function fails. So that's the concept here. Only run this function will only run if this function fails. Let me say that again. This another function will only run if this function fails. And of course, that means for you to test whether it fails, that means you are returning something from the function. So if you return 0, it means in your function you have made a logic that if I return 0, it means there is failure, right? So it means that's the logic you're testing. And then if I return something that is not 0, it means that there is no failure. So immediately this becomes a truthy value, maybe it did not return 0, then this will not be carried out. So that's how you can use this for short circuiting. Okay, so but in our current example, so we can say A less than B, and then we can say A greater than B. So if we have this, okay, let's compile this. Let's compile it to LOR. Run LOR. Okay, so this returns 1. Of course, A is not lesser than B, so this is 0. And then A is greater than B, so this becomes true. So that's why this becomes true. But if I do A greater than, let's check if A is greater than 13. Let's recompile this. Okay. Sorry, I've not compiled yet. All right, what's the value of A? 10, 5. Okay, so okay, so you see the value is 0. It returns, the result of this expression becomes 0 because A is actually not lesser than B and A is not lesser than 13. So that's why this expression would evaluate to 0. Okay, so just for us to understand the logical knot, right? It's just going to reverse, this will reverse it will reverse the condition, the whole statement. So remember, the only thing I'm changing here is I'm just adding the logical knot, right? So let me L knot. Sorry, I have to compile. So you can see with L knot, you can see that it becomes 1. So when I ran LOR, it was 0. But with the L knot now, that's the logical knot operator, it becomes reversed. So what this does is to reverse the evaluation of whatsoever is in the bracket. All right. Thank you very much, guys. I think we can stop here in this session. If you have questions, especially you have questions and you want me to make a video on short circuiting, please kindly comment, make a request in comment section. So based on popular demand, I will look for some time to make a video to explain more on short circuiting with the logical operators. All right. So if you are yet to subscribe to my channel, please do me well to subscribe so that you can get my videos every time I release them. And of course, If you like this video, I'll be very glad. Just click the like button, share with your friends, and that is how you will promote me. Thank you very much, guys. I will see you next time on Code with Matt.